Hi, good afternoon. So there are 143,000 public water systems in the United States, and here are two of them. One's a water vending machine. It's at a grocery store, and it provides extra filtration of the town water. And the other is a typical groundwater system. This happens to serve a commercial facility, and it consists of a well pump, a pressure tank, and a pressure switch. And there are no electronics, and there's no communication to the outside world. And so these are two of the 94,000 non-community water systems, and I believe that the majority of those have no risk or a very low cybersecurity risk. Many of the 49,000 remaining community systems are another story. So the water sector has a poor reputation when it comes to cybersecurity, and the EPA and CISA and the FBI all acknowledge that it needs help. And part of the problem is there are no federal regulations. So that when a water utility is like trying to decide where to, cybersecurity is a voluntary activity. So when it comes to coming up with like budgets and where to place attention, cybersecurity usually loses out to the real regulations. Over the past 3 years, the Department of Energy has provided or put out there $300 million of cyber grants. On the water side, nothing. So between the no regulations and modest community budgets, it's hard to engage the sector. In 2023, CISA and 8 of the national water associations got together to make a concerted effort to help water utilities take the first step. And they pushed hard and to have utilities sign up for the CISA no cost, low effort, Sci-High vulnerability scanning. And over a year later, 1% had signed up of the community systems. And that same year, the EPA had made it clear to all utilities that they were offering free cybersecurity assessments. And again, a year later, less than 1% had signed up. So it's hard to engage the sector. And because of all these things, it's a very easy target. A couple of high-profile events, sort of very simple but disruptive activities by the cyber army of Russia Reborn and the Iranian cyber avengers. Fortunately, despite its earned reputation, the sector has some real superpowers that can help it become much more resilient. One are water tanks, and water tanks are wonderful. So a normal water tank, or it's typical for a water tank to be designed to hold an average day demand of treated water at the right elevation that provides pressure. So if something goes wrong with the treatment system or a pumping system, there's a good chance that there are hours of time to figure out the problem and come up with a solution before there's a customer impact. And customer impact is really our OT metric. If there's an impact, you failed. If there's not an impact, you can have cyber events, and that's not such a big deal. The other thing is manual operations. The sector has a lot of experience and capacity for running in a manual mode. In 2021, there was a small survey of Massachusetts utilities, and 88% of the 127 respondents said they could run their full operations in manual mode. And I think that's kind of an overstatement, in part because the question, it didn't make clear that you don't have your HMI and you don't have your PLC. So I think some of them may assume they still had their PLCs, but it does give a feel for the extent of the capacity in the sector for manual operations. Boil orders and pipe breaks may not seem like a superpower, but in this case they are. They just happen pretty regularly. In 2021, there were over 4,000 boil orders in the United States, and in 2022, there was an estimated 160,000 pipe breaks in the US and Canada. So if something goes wrong because of a cyber event, well, that doesn't necessarily, it's a big deal if there's an aggressive attack that causes physical damage. It's a big deal, but it's not necessarily a catastrophe. Water utilities typically are logical islands. They don't have a need to connect to their neighbors, with a network connection. Fortunately, they can, and maybe not often, but they do have interconnections of pipes so they can share water, which is another, bonus in terms of system resilience. And then sort of maybe even with water tanks as a superpower of the operators, because they care about their system. It's their baby. They're used to failures. They're used to working out solutions. And then they also have sort of the normal human feeling of like, I don't want to get woken up in the middle of the night by a problem. And so they're very open to improving their systems. And if they have cybersecurity as one of the risks, they can become a real good driving force to help promote cybersecurity practices and these resilience practices in their utility. There's some other low-cost opportunities to improve resilience, cybersecurity resilience, and one is independent monitoring. So if utility has a SCADA system, they can install a data logger that's not connected. It's monitoring the critical parameters for that utility. And if the alarm set points are the same for the SCADA system and the data logger, then if you get an alarm on your data logger, well, maybe you have an instrumentation problem, but maybe you have somebody messing around in your system who's doing a manipulation and hiding it from the HMI. So it's a potential really good alarm system. And it also provides, if for any reason, cyber or otherwise, the SCADA system has to come down, it's a really powerful supplement for manual operations, being able to see what's happening at critical points in your system independent of SCADA. The water sector, because of budgets, particularly in the community systems, and there's typically just a single shift of operators. And so because of that, during off-shift hours, people want to know, the system owners and managers want to know what's going on. And so remote access is a pretty common thing. In that same Massachusetts survey, there were 61% of the respondents said they absolutely they needed remote access for running their system. And remote access is one of our big risks. But when you actually talk to managers and superintendents and explain, well, that lets you get in, but potentially somebody else could get in too. And then you say, well, could you live with just an outgoing alarm system? A good portion of them say, yeah, that would work for me. Because again, they're taking advantage of that water tank process delay time. So they have time to send somebody in to find out what's going on. Manual operations is pretty common, but utilities are not necessarily able to run their whole system. But I'm aware of one utility who was like, we can't run the whole system in manual. But when they sat down, their staff thought about it, they came up with a contingency plan. And while it wasn't ideal because it couldn't be permanently in place, if they had an emergency and they needed to do manual operations, they could spend about 2 hours of time reconfiguring, and then that would enable them to do full manual operations. If you have a system, suppose there's a critical PLC in your process, and it's a subsystem, and you can't run that ozone system, or you can't run that microfiltration without that PLC. Well, another alternative is to take it off the network. You can give the input and outputs to it, using hard wires. And so if the SCADA system goes down, you can trust that PLC to keep running that subsystem, assuming you have independent inputs for it. And then you can focus your real manual operations on other parts of the system. Another opportunity when it comes to manual operations is to have a backup control system. So in this case, this is a wastewater facility, and they set up a backup control system in one of their pump stations. And wastewater pump stations are really easy to do this kind of thing. In this case, they just had simple ladder logic and timers. And if that feels like too antiquated, maybe you could think of it in terms of using single loop controllers to be able to set up a relatively inexpensive backup system if your SCADA system fails for whatever reason. So the idea behind cyber physical safety systems is to create a non-networked way of preventing physical damage from a cyber attack. It can be an active or passive system. It could be in the form of having a mechanical object or a sacrificial element or an analog device or a non-connected digital interlock. And when you're thinking of these kind of solutions, they need to be ones that don't create more problems than they're trying to solve. So it has to be simple and reliable and have low maintenance. And the nice thing is, with this kind of approach, a retrofitted version is just as powerful and successful as one that's built in from the early design stages. Attending S4 in 2012, it was clear that a bad guy could take advantage of our SCADA system and do damage to our infrastructure. And specifically in certain circumstances, if somebody got in and turned on too many pumps, they would start breaking pipes. In 2013, Gus Serino came up with a solution. He realized that if we put an analog pressure switch downstream of each pump and you can see on the right there's a little nut, set that nut so the pressure's a little bit higher than what's normal, and if too many pumps come on, this pressure switch is going to send a non-networked signal to a non-networked pump controller and initiate an orderly shutdown. This is another example. This one's designed to prevent overdosing of sodium hydroxide, so lye. This was not designed with cybersecurity in mind. It was just there to prevent inadvertent errors, but you can imagine how the two go hand in hand. And in 2007, there was a community in Massachusetts. They had a maintenance error and an alarm problem, and the two together ended up with a slug of water that had a very high concentration of sodium hydroxide, and approximately 100 people went to the hospital with skin burns. And so it's useful to think of errors, I'll call them normal errors, operational errors that create problems. It's a good lesson for us in terms of thinking of what, there's a good chance that a cyber actor could recreate that if they get into the SCADA system or the DCS system. In this case, the downstream analyzer's at a point where the alum's injected in the system, and if the pH exceeds 7.0, then the analyzer sends a non-network direct signal to the feed pump, the peristaltic feed pump, and shuts it down. Here's some other potential ideas. So if you're worried that an adversary is going to create a danger or a hazardous vacuum, you could perhaps use a rupture disk. If your concern is water hammer, it's making sure you have the right gear ratio on your actuator. In the water world, pressure is a pretty big deal, so there are other ways to help control pressure. One is a hydrostatic tank or that pilot-operated pressure-reducing valve, or other approaches. If you think somebody's going to be messing with your rotating equipment, your pumps or your motors, maybe you set up a vibration monitoring system, and when things get extreme, it sends an independent signal to shut things down in an orderly way. If you're worried about, if you have a wastewater pump station again, and you're worried about somebody drawing down wet well level to a point where the pump's going to be starting to suck air. Well, maybe you install a low switch, or maybe you monitor the current draw, and if the pump is still running at a normal RPM and the current drops, maybe that's a sign that you're sucking air, and you're going to want to do an orderly shutdown. I'm aware of one system, and this was a maintenance error, but all these things translate really well to cybersecurity precautions, protections. They're doing maintenance on a hydro turbine, and they opened the wicket gates too far. That created the hydro turbine began shuddering pretty violently. It was kind of a scary event for the people who were present. And what the maintenance guys did was they took a steel pipe, or steel rod rather, and welded it to the piston to prevent it from having its full motion, to avoid having that reoccur from an error. But you can imagine if somebody got into the system and they understood how things work, they might try to do that through SCADA control. So if we take advantage of the nature of the sector and adopt some of those opportunities at a utility level, water sector can be really very resilient. And I like this chart. This is something from the FBI. It's an IC3 report from 2023, and it's showing the number of ransomware incidents by sector, and it has 249 healthcare ransomware events and 8 water ransomware events. And most likely that low water number is just like poor reporting, but I like to think of it as, well, this is an endorsement by the criminal underworld that, geez, water is really resilient and it's not worth our effort. They're just a pain in the neck because they never pay. So their challenge is to extend that resilience to the whole sector. And some that I talked about, it's the sheer number of utilities. There's an order of magnitude more community water systems than communication companies or pipeline companies or energy generating companies. There's that engagement factor, there are the resources. And then these next 3 things I'm going to clump together. These are not specific to the water sector, but I think of them as like potential single points of failure that can have outsized impact. And that's like the number of non-recognized penetrations by Volt Typhoon in the sector, the degree of shared service providers, and the incidence of large single owner companies, utilities that have multiple systems, either that they own or they take care of. And I kind of think of it as sort of like an amplification factor in a DOS attack. So the question is, how do we extend this resilience to the whole sector? I think there's 3 basic parts to that. There's the motivating the owner-operators. There's providing them with a good starting point for cybersecurity if this is new to them, and then also the resources. We're not going to get motivation from federal regulations. We're not going to get resources from federal funds. And so I'm thinking maybe on the motivation front, there could be a report of the past year's incidents, and I'm aware of 18 that had impact on business or operations. But if we had the EPA, CISA, the FBI, and the fusion centers cooperate, we could get a much fuller picture. And if a short report was put out without names, but categorizing the type of events and maybe their consequences, depending on the news cycle, you could get really good national coverage, I think. And if you had that, it seems like there's a good possibility that the owner-operators they'll be hearing it from their spouses, they'll be hearing it from all directions, and that will help motivate them to actually take action. And in the same the town managers and their system operators are going to be applying some pressure to say, hey, what are we doing? We got to do something. So that has a potential. So if we assume we have some motivation, the next is a good starting point. And CISA created the cybersecurity performance goals, and the EPA adopted them with just a few changes. But the problem is they don't address the really essential, the important things, the unique things about water systems. And so they don't directly address remote access, our biggest risk. They don't get into at all these opportunities for more resilience. You know, they don't talk about manual operations. They don't talk about cyber safety, cyber physical safety systems. They don't talk about independent monitoring. There's nothing about physically protecting your OT assets. There's nothing about, you know, using USB devices to transfer data between IT and OT. There's a whole host of things that are really important in the sector. And so I think it would be a big benefit to actually create a water sector cybersecurity performance goal. And I don't think it's a heavy lift either. So if you have the motivation and a good starting point, next is the resources. And this, you know, for this audience, this may be slightly sacrilegious, but taking advantage of the nation's CISSPs, they're in a voluntary way. There are 95,000 of them, and they all have to get 40 hours of continuing ed, and that can take the form of voluntary activities. And so I think with some proper guidance, like from this group, they could work really well to help low-resourced utilities and communities with things like the strengthening remote access, segmentation, access management. There are a bunch of things in their wheelhouse that can make a difference to water sector. So I think that's something that could really work. And I want to thank Mike Gorman. That was an idea he had. So when it comes to cybersecurity, the sector is in poor shape. But at a utility level, cybersecurity resilience can be awesome. And water has a real opportunity to be the most cyber resilient critical infrastructure sector. And I hope we can all help it get there. Thank you.